Hello everyone, welcome to SwitiSpeaksOfficial YouTube channel. I am Sweetie Pinjani. This is UVM Basic Series where we are learning basic UVM concepts from scratch. We had seen a lot of UVM concepts in the previous lectures. In case you have not gone through, please go through. Today we are going to learn in detail about a macro UVM field which is inbuilt in UVM object class, and UVM object class is inbuilt class provided by UVM. Why are we seeing this UVM field macro in detail? The reason is when you are writing your sequence items, you will have a lot of data fields, and for those data fields, we are going to use this UVM field macro a lot. That is why we want to understand about this macro in detail. What are the options in this macro so that we can use the right option at the right time. That is why we have to understand it in detail. And sequence item is very important in UVM because only with the sequence item, with the help of sequence item, we can generate a randomized stimulus for our UVM test bench. And those data fields inside your UVM sequence item will form that random stimulus. If we want to find how to correctly code that random stimulus, we have to understand UVM field macro. That is why today we will dedicate this lecture completely to UVM field macro. We had covered a part of UVM field macro, a gist of UVM field macro in UVM object lecture. In case you have not gone through, it is the previous lecture in the series UVM object. You can go through that because this UVM field macro is inbuilt in your UVM object class only. That is why I recommend that you first understand UVM object, then understand UVM field macro. As I said, UVM field macro is inbuilt in your UVM object class, and it will take two arguments. The first argument will be instance name of the variable. There will be a lot of variables inside your, say for example, sequence item. Say it is having the variables address, data, read, write bit. All these are variables. So the first argument will be instance name of that particular variable. And the second, and this argument should be compatible with the macro being invoked. What do I mean by that? Say for example, my variable is id, and this variable id is of type int. Then the macro which I am using should also be of type int. With this integer, I should not use the macro which is for byte. Why? Because my data type is int, so my macro should also be int. This is what I mean by the variable type should be compatible with the macro which is being invoked. Then the second argument is flag. This flag is something which specifies which data method should include the given variable. If you want to restrict your variable for certain data methods, say for example, I don't want compare operation on my ID, then I can restrict that particular operation with the help of flag. It is possible that you can OR multiple flag values. ORing operation is possible in the flag, or you can also use plus operator for adding the multiple flag values. If your flag is set to UVM all on, this is the default setting, then this variable will be included for all data methods. If you don't specify anything, this is the default flag UVM all on. It means your variable can be included in all data methods. What are various categories of UVM macros? This also we had discussed in UVM object series. In UVM object tutorial, we have a video tutorial on UVM object. Let us revise that. The first category is where you implement the data operations. Now these data operations can be for scalar. For example, scalars will be int, object, string, enum, real, event. Then what these field macros will do? For example, you are using UVM field int, then it will implement the data properties for integral. Similarly, UVM field object will implement data properties for UVM object based property. Then UVM field string will implement data operation for string. UVM field enum will implement data operation for enum. UVM field real will implement data operation for real. UVM field event will implement data operation for event. Then there can be one-dimensional static arrays. So here if you see, no need to memorize. It is very easy to remember. You just have to remember the category. And then for scalar, the prefix is UVM field. For one-dimensional static array, the prefix is UVM field S array. S array stands for static array. Then depending on the data type, you get the name. For example, if you want to implement the data operations for one-dimensional static array of integrals, then you will use UVM field array int. If you want to implement the data operations for one-dimensional static array of UVM objects, then you will use UVM field array object. If you want to implement data operation for one-dimensional static array of string, use UVM field array string. If you want to implement data operation for one-dimensional static array of enum, you will use UVM field array enum. Then you can also have one-dimensional dynamic arrays. For that we are using prefix UVM field array. For static we had used S array. For dynamic we are just using array. Then again depending on the data type. For example, if you are implementing the data operations for one-dimensional dynamic array of integer, it is UVM field array int. For one-dimensional dynamic array of object, it will be UVM field array object. This will be one-dimensional dynamic array of string. This is one-dimensional dynamic array of enum. Then we can also have queues. Queues are dynamic. If you want to implement data operation for queue of integer, use UVM field queue int. For queues, the prefix is UVM field queue. If you want to implement data operation for UVM based object, then use UVM field queue object. Then data operation for queue of string will be UVM field queue string. Data operation for queue of enum will be UVM field queue enum. Say you want to implement the data operations for associative arrays. These associative arrays can be indexed by string or by integer. Say your associative array is indexed by string. For that, you will use the prefix UVM field AA. AA stands for associative array. Then whatever is your data type, and since it's indexed by string, you will use suffix string _string. For example, If you want to implement data operations for an associative array of integers which are indexed by string, you will use UVM field AA, which stands for associative array. Then since it's an associative array of integers, it is int. Since it's indexed by string, it is string. Similarly, for associative array, this is again associative array of object indexed by string, associative array of string indexed by string. Then, as I said, you can also have associative arrays which are indexed by integral. For that, you will have suffix UVM field AA, stands for associative array. Then whatever is your data type, and towards the end you will have suffix int. For example, if you want to implement data operations for an associative array of object which is indexed by int, then UVM field AA object int. Associative array of integer indexed by integer, associative array of unsigned integer, this is unsigned integer indexed by integer. Then if you want to have associative array of integer indexed by int, then UVM field AA int integer, and so on. There can be a lot of different data types possible. Then there are certain recording macros. This recording macros will assist the users in recording. And then these macros, the first one is UVM record attribute. Now what happens? You have different vendors. And this UVM record attribute is a vendor independent macro. It can work for any vendor, but there are certain fields which are specific to vendor. So if you want to specify certain attributes, recording attributes for certain vendor specific transaction database, that you can specify using UVM record attribute. Then you have UVM record field. So UVM record field, what it will do? It will record name value pairs into the transaction recording database. There can be some name and value pairs which you want to record. Record that using UVM record field. Then there are certain macros which assist with packing methods. Here are some, and in this also there can be two categories. If you are specifying the size info or you are not mentioning the size info. With size info we use the suffix n. Then since it's for packing, it has UVM pack, and then whatever the type. Say for example, if you want to pack an integer, you will have UVM pack int and you are specifying the size, that's why n. For packing enum, it's UVM pack enum and specifying the size, that's why n. This will be for static array. This is for dynamic array. This one is for Q. Similarly, if you are not specifying size, then don't use the suffix n. So only use UVM pack as the prefix and your data type. For example, for int you will use UVM pack int. For enum use UVM pack enum. For string use UVM pack string. For real use UVM pack real. For static array, you have to use UVM pack S array. For dynamic array, use UVM pack array. For Q, use UVM pack Q. Similar to packing, exactly same, you will have the macros for unpacking. This will assist in implementing the unpacking methods. The list is same as you had here, only the thing is instead of pack, it is performing unpack operation. So the suffix is UVM unpack. Then whatever data type you have, if you are specifying size, you will have suffix n. If you are not specifying size, you will not have the suffix n. These are the categories of UVM field macros. Then let us understand about flag. As I said, there is UVM all on, which is default. If this flag is set, then it will be set for all operations. If you are giving some default setting, you can use UVM default. It will use the default flag settings. If you don't want to copy, then use UVM no copy. It will not allow the copying of the field. If you do not want to allow compare, use UVM no compare. If you do not want to allow print, use UVM no print. Then UVM no pack is, this will not allow packing as well as unpacking, because if you are not allowing packing, you should not allow unpacking also. Then you also have UVM reference. This is only for object types and it only operates on handle and it cannot do deep copy. There are two ways of copy, deep copy and shallow copy. UVM reference will not support deep copy. It is only for object handles, it is only for object handles and no deep copy. Then there is UVM physical. It will treat your field as a physical field and you can use physical setting in the policy class of this field. There are some physical settings also which you can have for the field. You can use that because UVM physical is treating your field as physical. Then there is abstract. This will treat your field as abstract and then you can use abstract setting in the policy class for this field. These are all the options available for the flag. Then UVM read only, it will not allow the setting of this field from set local methods or apply config settings. Why? Because it is read only. You should not be able to configure. You should not be able to edit. It is only read. These are various flags which are possible. Then if you want to specify the radix to print or record, there are various radixes which you can have. In order to specify the radix for printing or recording, you can OR your flag argument with one of the following. I'll tell you what are different radix. To use this, you have to OR your field argument. We had seen what are the field arguments. Various of them are possible. And the default one was UVM set all on. Now you can OR that with UVM bin. Bin stands for binary, which will have the radix 2, base 2. Then if you want decimal, print or record the field in decimal format, which is base 10, use UVM DEC. If you want unsigned decimal, use UVM unsigned. If you want octal, use UVM oct. It will print or record your field in octal, which is base 8. If you want hexadecimal, print or record your field with hexadecimal, which is base 16. Then use UVM hex. One important thing to remember, this is the default setting for your integral types. Whatever are different data types which fall in the category of integral, for them the default base is 16. Then you have UVM string, which will print or record the field in string format. Then UVM time is printing or recording the field in time format. There is some caution which you should have while using the field macros. The important caution is you should never ever specify a UVM component using UVM field object macro. Never use UVM field object macro for component. because this object macro is only for object, not for component. Unless the flag includes UVM reference. In reference, you can do this. If you don't follow this, what will happen? The field macro will implement a deep copy for UVM component, which is illegal. You should not implement the deep copy for UVM component. This is illegal thing in UVM. Then copy or clone of an object containing a component handle that was registered with the field macro without UVM reference flag. Then if you do this, you will get a fatal error. You cannot copy or clone an object containing a component handle which is registered with the field macro without using UVM reference flag. Then you get a fatal error. And also you will get duplicate entries when printing the component topology. This is creating a lot of mess. That's why never ever specify a UVM component in the macro UVM field object unless your flag includes UVM reference. Always remember this caution. Now we had learned a lot about field macros. Let's revise what we learned. We had seen that field macros, which is UVM field, is inbuilt in UVM object class. It takes two arguments. One is instance name of the variable and the flag. There are various categories of field macros. You can have the field macros for performing data operations, recording, packing, and unpacking. And there is one caution: you should never ever specify a UVM component using UVM field object macro unless the flag includes UVM reference. With this, you would have now clarified your UVM field. It is very important to understand this. You can go through this lecture a couple of times because only after understanding this you can understand UVM sequence item. Understand this properly so that later on we can cover UVM sequence item in detail, and there when I use UVM field macros you should understand what this UVM field macro is for. That's why I have covered this field macros in detail. We need this for the sequence items. To stay tuned to such lectures, especially in VLSI, you can subscribe to SwitiSpeaksOfficial YouTube channel. Myself, Sweetie Pinjani, will see you in the upcoming lectures. Thank you and stay tuned.